Hello everybody. So I am here to discuss about the failure of the induction motor. Generally, in a manufacturing facility, an induction motor failure was observed due to the combination of factors. The motor had been in service for several years without routine maintenance, leading to the accumulation of dirt and debris, especially in the air vents and around the motor windings. Additionally, there were signs of overheating, likely by poor ventilation and inadequate cooling. The lack of proper lubrication in the motor bearings has resulted in increased friction and wear, further contributing to the failure. So, these are some of the common cases where we can hear that there is a induction motor failure. In also certain cases, this causes underscores of importance of regular maintenance, poor ventilation, monitoring of environmental condition to enhance the reliability and longevity of induction motors in industrial settings. So now here, as per our case study, we'll speak about 6 major reasons for the failures. So coming to this, let the first one be our electrical overloading. So coming to electrical overloading, this in motor generally makes the motor to draw more current. And coming to the second point, it is nothing but low resistance. As the name suggests, the L effects of the providing low resistance in a motor. And coming to the third point, which is nothing but overheating. And fourth point, contamination, which is nothing but the accumulation of the dirts and the debris. And fifth one is the vibration, which is primarily caused due to the operation of the motors. Now let us discuss everything in detail. Coming to the electrical overloading. Generally, electrical overloading in the motor occurs when the motor draws more current than it is designed to handle. This can lead to overheating, reduce efficiency, and also potentially damage the motor or other connected equipments. There are several factors which can result in the electrical overloading in a motor. Number 1 is the mechanical overload. Number 2, voltage fluctuations. Number 3, phase imbalance. Number 4, incorrect motor sizing. And number 5, faulty or worn bearings. And number 6, inadequate cooling. Number 7 is inadequate or inappropriate connection. Coming to the second point, low resistance and its effect in motor. So now we can say that the low resistance, whenever it is provided to the motor, it can cause a severe short circuit as well as the winding damage, which thereby can affect the functioning of the motor. Say for example, they can be indicative of several issues primarily, and it can address the root cause to prevent the potential damage also to ensure proper functioning. So if the short circuit occurs due to a low resistance, the motor windings or the connections can lead to significant decrease in resistance. This can be caused by insulation breakdown, damaged winding, or a fault in the internal wiring. So winding damage, which is also a result of this, such as abrasions, cuts, or exposure to moisture, can also reduce the resistance. This damage may occur due to mechanical stress, environmental factors, etc. And coming to the next one is overheating. So the overheating is also one of the problems of motor failures. So this can very readily create, or it can it can also be caused because of the overloading beyond its rated capacity, which can increase the current flow and excessive heat generation. It is essential to ensure that the motor is appropriately sized for the load. Inadequate cooling can also be a reason for the overheating, and also high ambient temperature. Next, coming to the contaminations in the motor. So this contamination is primarily due to the dirt and the debris which is accumulated in the machine. And the next is the vibration, which is primarily caused due to the operation of the machine. So in this cases, the vibrations could be minimized with the proper seating arrangements of the machine. Thank you.